Hello, class. This is a recorded lecture for the second part of section 6.2, which talks about inverses of functions. Another concept that's very important in the math world. And the reason why we talked about the idea of a one-to-one function is that if you have a function that is one-to-one, when you take the inverse of that function, you end up with another function. And you'll see again, when you get into the more higher level maths, especially calculus, a lot of the ideas and concepts that you use are predicated on the fact that you can only use them if the equation is a function, especially derivatives. So before we talk about how to generate an inverse of a function, I think it's important to kind of walk back. What do we mean by inverse in general? And so what do we mean by that is this idea of undoing something, right, in math. And the two things that you need in it when you calculate an inverse is the two ideas. Is the idea, number one, is the operation. And the second idea is you need an identity. And what do we mean by both of those? Well, let's go back to our old arithmetic days, is that if we consider the operation addition. Well, the idea is that if you perform that operation, the identity is that when you do that operation, out comes the exact same number. So the identity for addition is 0. And so what we mean by that is 5 plus 0 equals 5, minus 7 plus 0 is minus 7. I think you get the picture here. So what is the idea of an inverse is that when you take a number, for example, 5, what do you have to do to that number to get the identity back? Well, you could see, how do we undo it, right? We use minus. So if you do 7 minus 7, how do we get 0? It would be minus, again, that same number. So you could see that the process of identities with addition. So say like we do multiplication now. So this would be multiplication. And so what's the multiplicative identity? It's the number 1, right? So that's your identity. So again, if you take the number 5 times 1, you get that number 5 back. So again, how do we undo this? How do we take the number 5? And if you do the multiplication of something, right, you get 1 again. Well, how do you undo multiplication is division. So what do? You divide by 5, or you do the reciprocal of that number, right? So 5 times 1 over 5 is 1. So like you had the number 3 halves. What do you need to do to 3 halves to get the number 1? Well, you do the reciprocal or divide by 3 halves, and you would get 2 over 3. So what do we do with functions, right? Well, the idea of a function is the function operation is the f of x part of it, where, remember we were doing the composition? That's why we introduced that. So it would be f of x. So we end up doing composition of a function. And what's the identity? And that's the key aspect of it. Well, I have to say the mathematicians pick something nice. The identity is y equals, whoops, I said y, but I wrote x. Let me try that again. So the identity is y equals x. So when x equals 1, y equals 1. When x equals 2, y equals 2, et cetera, et cetera. And so what's nice about that, it's this nice straight line that we have right here with a slope of 1. and the x and y intercept is right at the origin. And so the idea is, how do we generate these inverse functions now, knowing this is the operation and this is the identity? So that's what we're going to walk through in the rest of this lecture. So a couple quick terms just to make sure. Term number one is that we use this -1 up there sometimes to indicate inverse. And it's not to the -1 power. So it is a little bit confusing. So this doesn't mean that you bring it down into the denominator. So when we talk about that, that's what we mean by inverse. And the good news is that the idea of calculating an inverse is kind of nice. Is that basically, because we're talking about inverse and we're switching things, is that basically if you're given an equation, or we're going to start with ordered pairs, basically what you do is you flip the x and y variables, just flip them. So wherever you see x, you put y, and wherever you see y, you put x. And what's nice, let's start with this. So say like you had this relationship with these four ordered pairs. And basically, if this is the original ordered pair, we'll call that set H. The inverse of that ordered pair is you just flip them. So you could see the -8 goes from x to y, and the 5 goes from y to x, and so on and so forth. And so it's not too bad when you think about it. Here's another one that's a nicer one to take a look at. And say like you have set G. Now again, we just have 3 points, 2, 4, -1, 3, and -2, 0. And those are graphed here in the light red. And nope, I'm sorry, is graphed in the light blue. And so you could see when we do the inverse, which we flip these, the 4 becomes the 4 here, y equals 4, x equals 4, x equals 2, y equals 2. And you could see that it's a reflection right around the line, which is our identity, y equals x. And so the idea of this calculation is the reflection around the identity equation y equals x. And so what do we do with equations? Here you go. And so if you look at this equation, you could see that if we start with y equals x squared minus 2x, and what do? Well, if we try to find the inverse, the idea is, here we go, x for y and y for x. And so you can see how the relationship gets converted. And the idea is, what do those two graphs look like? Well, the blue graph is our original equation, y equals x squared minus 5. And you can see that the red graph is x equals y squared minus 5y. And as you can see in this case, because the parabola, right, the quadratic equation is not 1-to-1, when we generate the inverse, you can see the inverse is not a function. So again, if we look at the blue, the horizontal line test tells us we're not 1-to-1. And if you look at the red, you can see the horizontal line test, or the vertical line test, excuse me, tells us that we don't have a function. And so that's what we mean by this, is 1-to-1 functions and inverses. So if the function is 1-to-1, then the inverse will also be 1-to-1. And again, this idea of the horizontal line test will tell you that. That is by far the best way to do it. And then for the function, the vertical line test is by far the best way to do that. So let's walk through an example with regards to the calculation. And so here are the 4 steps. Is what you want to do is you want to replace x for y and y for x, but then you also want to solve for y again, Because remember, all our functions that we set up are y equals x aspect of it. And remember, x is the domain and y is the range. So the x is the input variable and y is the output variable. So let me walk you through a typical calculation that we'll be doing in this section. Okay, so say like we have the equation y equals 2x minus 3. Now remember, if it was stated f of x equals 2x minus 3, you could just replace the f of x with the y. F of x implies that what? That we actually have a function, but it's still that idea of the y variable on the Cartesian coordinate plane. And I think we know, hopefully, is that we have a nice linear equation here, right? And so a linear equation is a nice straight line, and it is a one-to-one equation unless it's a horizontal line. And so if it doesn't have a slope of 0, we're good to go. Here, our slope is 2, so we're good to go. So let's find the inverse. So the idea of calculating the inverse is going to be replace the y value with x, and then we replace the 2y or the x value with y, and then we keep that variable, the constant variable, the same. So what we do, just solve, right? Now we solve for y. We have to do a little algebra. We'll bring the minus 3 to the other side. You have 2y equals x plus 3, and then you divide each side by 2, and the inverse is y equals, you could write it this way, or you could leave it the way we had it there, 3 over 2. And so you could see that this is also a linear equation, right? And the linear equation would be 1/2 x plus 3 over 2. And so now we have a slope of 1/2 and a new y-intercept of 3 over 2. And if you take a look at the graph of these two, it would look like this. So here's our original equation in green, and here's our new equation in red. And those two inverses are a reflection over the line y equals x. And the only time they'll intersect is when the x and the y values are exactly the same. And it looks like in this case, that's the value 3. So when x equals 3, y equals 3, you can see those two are the same. But when you're talking about this idea of inverses, how do we get back to this idea of operation, which is the composition, right? And the identity y equals x. So here's how you prove these are inverses of one another. So say like I define the blue equation as f of x, and so we'll call it 2x minus 3. And say like I define the red equation as g of x. And that would be x over 2 plus 3/2. And by our definition of these inverses is f of g of x also equals the same as g of f of x. And the output will always be x. So you can think about the output's always going to be y equals x. So let's do that. Let me do, it doesn't matter. Let me do this one here. So g of f of x would be g of 2x minus 3. And so when you plug that into the equation, you need a little bit of space here. So let me pause here for a second. And okay, back from my erasing. Give me a little space here. So as I've noted here, when we plug that in, wherever you see x and g, you're going to plug in the 2x minus 3. So you could see that this would be 2x minus 3 divided by 2 plus 3/2. So let's do a little bit of simplification. So we could rewrite it this way. This would be 2x over 2 minus 3/2 by splitting this up and putting the denominator under each one of those terms. And then you get plus 3/2. So you could see these two cancel and give us 0. This goes to a 1, and you can see that equals x. And I'll let it to you to do the other one. F of g of x will give you the exact same answer. So the idea of being able to do this in either order with regards to the inverse calculation is one of the attributes that you have when you talk about inverses of functions. So let's just do one more with regards to that. And so let's say y equals 2/3 x plus 5. And you want to do the inverse. So when you calculate the inverse, we'll replace the y with x, and we'll place the x with y. And so when you do this calculation, we want to solve for y. So again, we try to isolate the variable by bringing the plus 5 to the other side of the equal sign. And then you can see what we want to do is multiply each side by 3 over 2. And so you would end up with y equals 3 over 2 times x, and then that would be minus 15/2. So this ends the recorded lectures for section 6.2 and the idea of inverses of functions.